what's up guys? Today we're going to solve this question, count unguarded cell in the grid. So I'm just going to straightforward to the point what this question wants us from. So I just drawn a grid in which, as you can see, G denotes a guard and W denotes a wall. So guard can only see in four direction, which is in this way, which is right, in this left, and this above and then bottom. So for the instance right now, as I can see, guard can look whole all of these cells since there is nothing obstacle, not even a wall. But in this situation, as I can see, let me just change the color to red to make it more clear. Wait, yeah. So as you can see right over there is a wall, so which is blocking the vision of the guard. So guard cannot see these further columns, I mean these cells. So that's it, that's about this guard. And we move on to this guard. This guard can see this cell which is already seen by this, but anyway, we move on. This guard can see bottom, all these cell and this one. Since wall is blocking, this guard cannot see this wall. Then after that, in above case, as also it is wall which is blocking. So in similarly, we're gonna do the same for this guard. He can look over there and at this place and at this place and this is blocked. So in this way, we can count that these are the cells which is basically unseen. This one, 3, 4, 5, 6, and then 7. So that's the question one. They want to solve this question in this way. As you can see, the output of 7. We want to count the number of unseen cells. So how can we do this? So basically in this question, they're just given it the positions in which card present, but there is no grid. So what we can do, we can make the question much easier. We just simply need to do this. There is a pretty simple algorithm, although it is a brute force, but it will be efficient if we move forward. So let me just show you what this means. So let's say I'm at this position right now. I mean, just change the color again. I'm at this position right now. I have a guard. What I can do, I can create a loop and I can move in four directions. So for right now, I'm in a loop in which I'm checking the bottom. So I have reached here. What I can see, there is nothing, and this card can guard this place. So I'm going to mark it as flag, like I visited, just a number 3. Then after that, what I can do, again, I'm going to check. Is there a blockage? No, there is. I'm going to mark this. In this way, I'm going to mark this whole place. Then I'm going to run loop over here, but it is outbound. It doesn't go in work, either in this way, and this is blocked, which I've explained already. So what I will do, I will move on to this portion. In this, I'm going to check it this place, which is, what do we say, right to left. This is marked as 3, which means the guard, this area is guardable. Then after that, I'm going to run a loop in this direction, mark it as 3, then 3, and in the same way I'm gonna do this, mark it as 3 then 3. And in the end, once I reach over here, what I can see, if I try to run a loop, it's gonna stop right over since I have a wall right over there. But if I try to run a loop over here in this direction, it's gonna mark it as 3, and then in this direction is 3, although it is repetitive work since it's gonna mark 3 again, but it doesn't matter since the code is kind of efficient to solve this question. Then 3. In this way, what I can see, there are some area which is, I mean, if we initialize the grid as a value of 0, there are some area whose value is 0. And if we try to count these values 0, we will be able to get our answer. So there's a pretty straightforward solution for this question. Although it is medium, but if I try to do a loop, it is kind of easy. So what I'm going to do, first of all, I'm gonna create a grid. How can I create a grid? So in Python, we can do like this. We're gonna create a grid of this. So first of all, n of this much, n. So it's gonna give us the number of columns. So basically what it does, it's gonna create as many as 0 as the given amount of n is. Then after that, I'm gonna run a for loop in which I'm gonna give the range of m so that I can create a grid, a 2D grid of this. So in this way, after that, I'm gonna tell you guys that we're gonna mark guard as value 1, we're gonna mark wall as value 2, and guardable area as value 3. I mean, I guess the spelling of guardable is kind of incorrect. Now it is correct. Then after that, what else we can see? I mean, the value which is empty, which means that this is unseen. So which is already mentioned over here, which is the value 0. So what I'm going to do, I'm going to iterate over the first guard array and simply going to do this. Guard this. And then I'm going to, in my grid, I'm going to mark this row and column as 2, which I've mentioned, I mean 1, which I mentioned earlier in the above. Then after that, I'm going to do same for the walls which I have in the question, and I'm going to mark it as 2, which is already mentioned like above. Then after that, what I'm going to do, I'm going to do a row and column in guard and gonna look for all 4 directions. So for 4 direction, I'm gonna call the function 4check. I mean, it's a 4 direction check set, so its name is 4check, and I'm gonna pass row and column in it. Then after that, what I'm going to do is I'm going to create this function. What this function does is kind of simple, which I've explained right now. So 4check, as I mentioned, it's gonna run a loop of 4 directions. So let's say first we're gonna do from bottom up, and I mean it could be, yeah, it is top down. So in top down, what we can do, we can run a loop of row since row moves into up to top to bottom. As you can see, row is like this, and it is top to bottom. So in this way, we're gonna give a range of what, r plus 1, since we don't actually want to count this row, we want to count next of it, which is this place. So that's why it is row plus 1, and the column is going to be, I mean, row is going to be m. Then after that, what I'm going to do is I'm going to do row of this column, it's going to mark as 3 since it is guardable. But what if I encounter what do we say, what if the grid row and then columns comes out to be 2, which means that there is a wall. So I cannot go further. I'm gonna break. And also one more catch. If I try to do one, it's gonna make the code more much easier since if what if there is a guard just next to it. So I'm gonna stop right over here at this portion, and simply the guard over here will run their own 4 directional loop and it's gonna check. So that's why I'm doing this. Then after that, what I can do, I can just simply copy and paste 4 times just to make it more easy for all the 4 directions. And just let me zoom out since yeah, I mean it's kind of big code, but it's a pretty straightforward code. So then after that, what I'm gonna do is I'm gonna do a bottom up direction loop, which is bottom up like this. I'm gonna say row, and what I'm gonna do is basically r minus one, then minus one, and then minus one. So what that is it do basically is gonna run a loop in an opposite direction in this way, in which it's gonna just not going to check this, but it's going to check the above cases. So in this way, it's gonna do the same thing. Then after that, what I'm going to do is I'm going to do a horizontal search, which is from left to right. And in this way, we have right over here, we have this column is this, and then column in this, we're going to move column, so it's going to be constant. And instead, I mean, not, yeah, I mean, it's going to be constant. Then we have column, we're going to move column plus 1 up to the n, which is the last value. It's going to remain row is constant, whereas the column is movable. In the same way, in this row is constant and the column is movable. Then after that, I'm going to do a horizontal search from right to left. And in this way, we're going to say column minus 1, then minus 1, and then minus 1, so that it can look in that direction. It's going to be a column, and the row is going to be constant, and column is going to be this. I know it's a repetitive work, but I mean that's how Quotient works in a loop. In this way, we'll be able to mark all the three. So once we do this, we're going to initialize the result as 0. We're going to look over rows in our grid. Then after, I'm going to look for each element in my row, and I'm going to check if this element equal to 0, which means it is unseen. If it is unseen, I'm going to increase the R result, and in the end, I'm going to return the value of result. Hopefully, this code will run. I mean, even I'm not sure, but I think it may run. So yeah, it works fine, and that's how we do it. Yeah, that's it. Okay, cool.